This is a question to prove similar shapes learned in 3rd grade of junior high school. This is a standard question, so try working on it after you are able to prove basic similarity. For 2, you don't have to write a proof, but be sure to be able to confirm that the similarity condition holds. In 1, we prove that the ratio of BD and CA is equal to the ratio of BE and CD. For questions like this, you can prove the similarity of the triangles using these lengths and prove that the ratios are equal. Blue triangle BDE and red triangle CAD have equal base angles based on the assumption that they are isosceles triangles, so angle B and angle C are equal. Using the assumption that angle ADE is also equal to these base angles, let's consider whether we can find another set of equal angles. When you think about how you can use the hypothetical angle ADE, I want you to realize that angle ADE is part of the exterior angle of the triangle CAD. The exterior angle of a triangle is equal to the sum of its two interior angles that are not adjacent to it. The corner obtained by adding the red angle C and the green angle CAD becomes the blue angle ADB. The red corner parts are the same, so you can see that the angle BDE part is the same size as the green angle CAD part. I'll write a proof. In 2, find the length of EC. I am sure you'll think of various ways to do this, but please consider whether there is a triangle that is similar to the triangle EDC that uses EC. Since the ratio of the two sides of triangle EDC is 3:2, if there are other triangles with the same ratio of 3:2, they may be similar. This red triangle AED also has a side ratio of 3:2. If the similarity condition holds between these two triangles, then the angles between them must be the same side. The blue angle EDC and angle AED between 3:2 are at an alternate interior angles. Therefore, if there is evidence that AE and DC are parallel, the alternate interior angles of parallel lines are equal, so we can say that blue angle EDC and angle AED are equal. Since triangle ABE is an isosceles triangle by assumption, the base angles are equal, and angle ABE and angle AEB are equal. From the assumption, angle ABE and angle DCE are equal, so all three angles are equal. Since angle AEB and angle DCE are equal, the same angles are equal and AE and DC can be said to be parallel. This seems to explain why the similarity condition holds. There is no need to write a proof this time, but I will write one just in case I need to write one. Write that the ratio of the sides of both triangles is 3:2. Since both ratios are 3:2, we can say that the ratios are equal, so we will write down 2 equals 3:2. To explain that they are parallel, we can write that the base angles are equal, and from the assumption that the angles are equal, the angles are equal. Since the alternate interior angles of parallel lines are equal, we can write that the angles between two pairs of sides with equal ratios are equal. Now that we have confirmed that they are similar triangles, all we need to do is set the length of EC to be x and create an equation that shows that the ratios of the sides are equal. The ratio of 16 to x is equal to 12 to 8. The orientation of the triangle has changed, so be careful not to mistake the corresponding side.